You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Imperva helps organizations protect critical applications, APIs, and data anywhere at scale and with the highest ROI. With an integrated approach combining edge, application security, and data security, Imperva protects companies through all stages of their digital journey.
Hello, and welcome to another episode of the New Stack Makers podcast. I'm your host, Lorraine Lawson, a reporter with TNS. Is ShiftLeft, the push to bring security to development, overrated? We're talking about the limitations of the ShiftLeft approach today with Peter Klimek, Director of Technology with Imperva's Office of the CTO. Thank you for being here today, Peter.
Thanks for having me back on the show. It's great to be here.
We'd also like to acknowledge and thank Imperva for sponsoring this episode of Makers. Peter, let's start by telling our viewers a bit about Imperva and what it does.
Sure. So Imperva is an application and data security company. We've been protecting applications and critical workloads for organizations for over 20 years now. We primarily focus on edge protections with web application firewalls, DDoS mitigation, bot protection, and most recently focused on API security.
Okay, so very relevant to what we're talking about here today. ShiftLeft is one of those buzzwords that everybody has heard over the years, but what is it really and what problems does it solve, especially for developers?
Sure. So I think the history of ShiftLeft ultimately goes back some years now. And ultimately, the goal for it is to build security earlier into the software development lifecycle. And so if we think about the software development lifecycle as really a timeline from design all the way to production, then you can think of the shifting left is moving more of the security checks earlier into the software development lifecycle. And that's been really the stated goal of it. It's not a new concept. It has been around for quite a while. I think the term was originally coined in the early 2000s. And it was really popularized in the late 2000s with Microsoft when they released their SDL, which was the Secure Development Lifecycle. And the goal here really is that you're trying to find and fix vulnerabilities as soon as you can. So closer to the point at which they're created by development teams, with the impetus being that you can develop and release more secure software. And it's also cheaper and more cost effective to fix those vulnerabilities earlier in that process.
So on the face of it, it makes sense, but there's also this other side of ShiftLeft, and that is the backlash you're seeing by both developers and security leaders, interestingly enough. So what are you hearing and seeing in the field?
Yeah, so this was a really interesting one for me. It was actually first brought to my attention, I think, in the last podcast recording that I did with the New Stack. And it was a quick question just asking about some of the backlash that we're hearing from the development side on ShiftLeft. And this got me thinking. And when I started going and querying and polling various CISOs in the organizations, I found that the pushback wasn't just limited to developers. It was also security professionals that were starting to push back on it. And so that was what was really interesting for me. Now, some of the big reasons why we're hearing some pushback around this is really, if we think about what security teams are trying to do with ShiftLeft, is they're often trying to detect these vulnerabilities. But most organizations and most CISOs, when I talk to them about their top priorities, and even developers here, the problem wasn't necessarily finding the vulnerabilities. The problem was actually getting the time to fix the vulnerabilities that they already know about. And this is really where a lot of that pushback is coming from, is that most organizations are looking for not ways to find and detect things. They're already doing that quite a bit, but it's also then focusing on their ability to actually get time to fix the things. So that's one side of the equation. There is a second one, too, that we're seeing, and this is kind of the perspective that we have from the Imperva side, being defenders of applications, is that a lot of the attack vectors are also moving towards vulnerabilities that aren't necessarily detected with ShiftLeft tools. And so this is the other part of that pushback to the equation that we're hearing about.
Yeah, you told me there were more business logic abuses or attacks than the traditional attacks that we think about. Would you explain what that means and specifically how it's relevant to the ShiftLeft approach?
Yeah, so everyone knows in terms of common vulnerabilities that organizations have to deal with on a regular basis. There's some big name vulnerabilities that are out there. These are the Apache struts and the Log4Shells and the ones that always get, a lot of press and attention because they really go and they target every single organization, and oftentimes they're targeting your dependencies. These are the type of vulnerabilities that are good for shift-left tools to be able to find, although oftentimes one of the bigger challenges that you have is when a big zero-day vulnerability comes out, that you oftentimes have those workloads already running in production. And so you need some mechanism and some capabilities to buy your development teams time to get back and to actually patch them. But then there's this other class of vulnerabilities that we look at, and we generally coin these business logic vulnerabilities as a higher level categorization. And business logic vulnerabilities are really something that's targeting how the application actually behaves. And so a lot of times what we're seeing here is things like authorization vulnerabilities. Authorization decisions within an application are usually closely tied to the business logic of the application. And by them being tied to the business logic, this makes it very hard for you to use shift-left tooling to identify those vulnerabilities earlier in production. Similarly, we know that there's lots of vulnerabilities and attack vectors out there that aren't even necessarily targeting your code, they're targeting your users. Good examples of this are things like account takeover and credential stuffing attacks. These are really preying on the inherent weakness of reused passwords that everyone has across the organization. And just in terms of the sheer magnitude of how big this problem is, there were over 700 million password pairs, passwords and usernames leaked onto the dark web last year alone. And the corpus of data right now that attackers have to pull from is about 24 billion total records. And so if you think about how organizations have to protect and defend against those vulnerabilities, they're not really things that you're going to code into your actual application logic. They're things that you have to be able to defend really with other tooling.
Yeah, so maybe less zero-day flaws and more ongoing challenges. What burden does ShiftLeft place on development teams? You touched on this a little bit, but why do they see it as problematic? How does it affect them?
Yeah, so I think where the burden has kind of shifted is before we got to this point of advocating for shift left, a lot of times the security teams were really the ones that were responsible for defending and protecting their applications. And a lot of times they were the ones that were kind of running these scans, and they were looking and trying to get the development teams to own the vulnerability remediation process and take this in there. Now, more of the shift left tooling has shifted the burden to development teams, which isn't necessarily a bad thing. But ultimately, some of the challenges that we'll see is then when so much of that burden starts shifting to the development teams and the security teams aren't doing enough to really protect the applications, that's when that balance really starts to shift. And now the way that we typically look at it, and when we start talking with CISOs about this problem, I think one of the most common questions that we ask is, how can you actually identify if you've hit this point? If you've actually gotten to this point of, is this a burden? And I think this is where development teams really have some responsibility to understand their own metrics in terms of how productive they are. Because ultimately, if you want to make the case that something is impacting you, and you want to make the case that this is something that's really too onerous for you, you need to have good mechanisms and good before and after data to point out that this is something that's slowing down our pipeline. This is something that's really slowing down the way that we work as development teams.
Yeah. And you've talked about the Dora Metrics a little bit. Do you want to go into a little more detail about that and what sort of Dora Metrics you can look at?
Yeah, the Dora Metrics, for anyone that's not familiar, this is a project. It stands for the DevOps Research and Assessment. This is a project that was created by Google and founded by a team there. And what they have is some very simple metrics that organizations can use in order to understand their overall development team velocity. We like this metric because ultimately what this really looks for is the things that development teams really care about. This is things like lead time for changes, deployment frequency, change failure percentage, as well as time to restore. And one of the things that I strongly advocate to security professionals that may be listening to this is that the Dora metrics are actually really positive and beneficial for security teams as well. And the example that I always give here is if you look at an application development team that has to go back and patch something that's in production. Let's say there is another critical zero-day vulnerability that comes out, and you need to work on marshaling the resources of your development teams to actually get patches out. You'll provide some sort of protection for a little bit of time, but we know that the fix is to actually get this fixed in code. Then those are instances where you want application development teams that are able to move really quickly. I'll take an application development team that can get a code release out within 24 hours over an application development team that takes a month to be able to get code releases out and go through QA. And these are the instances where we see that there's a lot of value in security teams and development teams really partnering together.
Yeah. So you think we're perhaps approaching the peak of shift left movement? What do you mean by that, and why is that happening?
Yeah, so the peak shift left for me is really this point where the additional tooling that you're adding to your software development lifecycle is really doing more harm than good at this point. And so it's really kind of looking at that inflection point. For some organizations, they certainly haven't hit that, but for others, they're getting to that point, or they've already gotten to that point. We mentioned some of the metrics that they'll see, at least on the application team sides. Some of the other instances that you're going to see on the security team sides, you're going to be able to tell that you're hitting this point when you're effectively just finding a lot more vulnerabilities, but your actual change closure rates or your vulnerability closure rates aren't going down. So what we strongly advocate for security teams working in here is to get back into more of a defensive mindset. And so by being back into a defensive mindset, really the goal is we want to put guardrails in place that allow our development teams to go fast. We want them being able to push out code changes. We want them being able to support the business, but we want them to be able to do it knowing that in the event that there is a mistake or there is a critical vulnerability, that they have the ability to actually go back, and you have the ability as a security team to buy that development team the time that they need to actually go back and fix that. Certainly, you want to have controls in place for what gets into production and making sure they pass minimum code quality checks. But it's really about those other instances when something comes up that they didn't anticipate, that you need to have that defensive mindset in place.
Yeah, the Chicago Bears taught me that the best offense is a good defense. But I wondered, are there specific other things that security teams need to do, and how will that help developers?
Yeah, so I think for security teams, one of the other things that they can do that's going to be really beneficial for development teams is a process that we call threat modeling. Threat modeling is really a tabletop exercise that you can use as a way of basically looking at a system in its entirety and understanding what threats you're mitigating and how you can go through this process. Why I really like the threat modeling process is, first and foremost, there's nothing to buy. You don't have to actually go out and procure anything extra. It's really a tabletop pen and paper type of exercise or a whiteboard exercise. And it's also a really good opportunity then for the security teams to educate the development teams around the different threats that they face. A lot of times they can use their historical knowledge of how we battled a certain threat for a different business unit, or even in a past life working for a different company, to really talk about how attackers work. What are some of the mechanisms that they use? And then it's a good opportunity then for the development teams to really educate how the application works. What are those critical business functions? Especially when we're working with things like APIs, there's two things that we generally are going to look for. We want to know what are sensitive business functions, and we want to know what's risky behavior within the API. And those sensitive business functions, those are the things that typically get targeted in business logic attacks, where you're looking at things like carding vulnerabilities, or someone using a carding process to check for credit card numbers and seeing which ones are passed. ATO attacks. Those are the things that you can identify in a threat modeling process, and you can identify what the controls are, or at least what your response plan is at that point, to be able to go and mitigate those things. And I think that exercise is really just fantastic because everyone gets involved. It's a team sport. It's one of those things you don't want to just pass it over the fence and make the security team do it or make the application team do it on their own. It's really a collaboration exercise.
And you've touched on this, but has Agile and the rate at which development is produced through Agile played into the security and the shift left movement?
Yeah, so I think the Agile movement was really one of the big drivers for the shift left movement, or at least the maturity of the shift left movement. Agile really emphasized the need for it, especially as teams went from going and releasing once every 3 or 6 months to now releasing on a daily or even weekly basis. And this is really for security teams where they try to adopt more of the tooling going into the software development lifecycle and further left into it. Now, Arguably, though, one of the bigger challenges that you have as you're pushing out more code more quickly, then you do need those production controls in place. And they actually become probably more important because the teams, especially the teams that are doing multiple releases per day, there is instances where they're just simply not going to be able to run a lot of these scans at a full level. It's similar to how they generally probably won't be doing full regression testing with every single release. And so you need to have that extra level of control in place in those very, very fast Agile development life cycles.
Now, you told me you were a front-end developer at one point. Is that correct?
That is correct. Yeah, I still do it.
Still do it. Okay, great.
Yep.
So I write specifically for front-end development a lot of the time, and they're always in the back of my mind, and they don't get talked a lot about when it comes to security in the front end. So is there a way in which this affects front-end developers specifically and that things they should be aware of?
Yeah, there's two things in particular, I think, for front-end developers that really come into play. I think first and foremost, there's been a big shift in terms of how applications are written. We went from kind of server-side rendered applications to single-page apps, and a lot more of that business logic actually got delivered or gets delivered now in the front end itself. This is really important, I think, with API development, because if we think about state and state management within an application, state is now hosted on the client side. It's the front end that's actually responsible for this. Most APIs, especially well-designed APIs, tend to be stateless in nature. This is part of the reason why we see an increase in business logic attacks going against those APIs. So while the core protections are usually focused around the APIs, there's a lot more that gets managed directly on the client side. And so organizations need to be very careful around how they're actually securing and storing that data. Are they using things like JOT tokens in order to be able to do that? These are some of the threat vectors now, I think, that have really kind of entered the parlance of a lot of front-end developers that they previously weren't working with, because now they're actually holding this critical information. The second attack vector that we also see here is, you'll hear it commonly referred to as things like mage cart attacks. You can think of mage cart and effectively the categorization of attacks as digital skimmers. So similar to how you've probably seen photos of like credit card skimmers at a gas station or things like that, mage cart style attacks work the exact same way, but the way that they often will embed themselves is through malicious dependencies in third-party libraries and frameworks. And this is a big, big challenge that a lot of organizations are now battling and dealing with, especially as PCI DSS 4 is coming out, because it specifically calls out mitigations for mage cart type of vulnerabilities and protections. And so what we're looking for here is usually the security of the dependencies that JavaScript developers and front-end developers are pulling into their code, as well as the interaction with third-party libraries and frameworks that they have on there, and specifically looking to protect things like credit card information. So absolutely, for those developers, they should also be part of the threat modeling exercises because they're no longer immune from it.
Yeah. So I have to ask, everybody's talking about it. There's just people are tired of talking about it, but there's no getting away from it. That's artificial intelligence. How is it changing the threat landscape, and how will it change how we respond to the threat landscape?
Yeah, it's such a good one. We're seeing it in a couple of different ways. I think starting from the attacker side, because that's where I spend a lot of my time thinking about. One of the interesting things that we saw last year this year in our Bad Bot report, which looked at all the data from last year, was bot authors. So people that are writing malicious code to do things like buy sneakers or Taylor Swift tickets or, anything else. Yo-Yo Ma was the most recent one that we saw. His tickets were going for quite a lot. These are bot authors that have become far more sophisticated. And so effectively, we've squeezed out the middle class of bot authors, and the ones that were previously not too advanced have graduated to now become advanced bot authors. We're seeing this across the board now. I think with generative AI tools, what you would traditionally consider to be like a script kiddie, which is someone that's just using tools that have been written by someone else, using a lot of the generative AI tools, same things that developers are using as well. We're up-leveling the script kiddies. They're getting more dangerous. They're getting more better tooling with them because they can focus on writing these threats. And so this is one of the bigger things that we are tracking and seeing across the board. Now, the flip side of this, of course, is for developers, there's a lot of additional tools and benefits. I love GitHub Copilot. I use it all the time. It makes my life a lot easier. And so the tooling itself is getting a lot better. I think in the terms of the shift left story and where we are seeing a lot of value still in there and some mileage for shift left tooling, it's specifically around things like unit testing and integration testing, those fun things that developers just absolutely hate doing and writing. Being able to generate codes, tests that can do things like fuzz testing your application and checking for input validation and not having to write all those things anymore. These are the things that I think are very beneficial with the AI-based tools and being able to support that.
You'll have to be patient with me. I can't remember what it's called, but what about this approach where you develop the test first and then you work? What's that called?
Test-driven development.
Test-driven development. Yeah, makes perfect sense. Okay. How does that fare in this world?
Yeah, I think it's a great practice for a lot of development teams if they're in that behavior and they're doing that. I think ultimately, if they can get into a process where they can even think about what are the security controls or security concerns that we have as part of the test-driven development, so not just coding to your specification and writing the test to the specification, but also thinking about abuses of data input right at that point, then that's really what we're looking at for being able to do that. And if the AI models are able to effectively go and generate some of these tests for you as you're going through the process. So a good example here is how does this application process non-Unicode characters that we would typically see? Those are good examples that attackers are always going to try. And so by being able to auto-generate some of those types of tests, that's ultimately where we get to a point where now we have the AI tools that are able to effectively combat some of the gains that the attackers are making through them as well.
That's a wrap for this webcast. I'd like to welcome our guest again, Peter Klimek, for joining us today. Peter, are there any places where you'll be that maybe developers could meet you and talk to you in more in depth?
Sure. I think one of the biggest shows of the year that we've got coming up here is going to be AWS reInvent out in Las Vegas at the end of November. So Imperva will be there. We'll have a booth available and come on by, especially if you're interested in learning more around things like account takeover protection, bot protection, API security, any of those different things. Always happy to talk shop and talk about the various trends that we're seeing in the application development space and security space.
Yeah, that's a great conference. And we'd also like to thank Imperva, our sponsor for this episode. Thank you for joining us. We'll see you next time on the Maker Podcast.
Thanks so much.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.